we need to balance the redox reaction for a nickel-cadmium battery. So here's what happens. Solid cadmium plus nickel oxide hydroxide give us cadmium hydroxide and nickel hydroxide. In the battery, this takes place in basic solution. So we've already seen how to balance a redox reaction in basic solution. So I showed you a video with all of the steps. So this video is a review of what to do. Remember, you pretend like it's an acidic solution, and then you can change it to a basic solution. The first step is to assign oxidation states. So we start with solid cadmium, and for cadmium metal, this is an element, so the oxidation state is 0. Next, for nickel oxide hydroxide, we know hydroxide is OH minus, and oxygen is O2 minus. So therefore, nickel must be nickel 3 plus to balance that out. So this must be nickel 3 plus ion, which has an oxidation state of +3. For cadmium hydroxide, we know hydroxide is a -1 charge, and we have 2 of them, so this must be cadmium 2 plus ion, which has an oxidation state of +2. For nickel hydroxide, same thing. We have 2 hydroxides, so this must be nickel 2 plus, the nickel 2 plus ion, meaning the oxidation state is +2. So first we write our oxidation half reaction. So let's do that. So what is oxidized in our battery? Solid cadmium is going from an oxidation state of 0 to an oxidation state of +2 in cadmium 2 plus. That's an increase in the oxidation state. So that's oxidation. So we write down our half reaction. We have solid cadmium going to cadmium hydroxide. Next, we look at the atoms that we need to balance. So let's start with cadmium. We have 1 cadmium on the left and 1 cadmium on the right. So cadmium is balanced. Next, we balance oxygen. So how many oxygens are on the right side? Well, there's 2, because this 2 applies to everything in the parentheses. So there's 2 oxygens on the right and 0 oxygens on the left. We balance oxygen by adding water. So how many water molecules do we need to add to the left side to balance oxygen? We would need 2. So if we add 2 water molecules, now we have 2 oxygens on the left and 2 oxygens on the right. Next, we balance hydrogen, and we are going to pretend like this is in acidic solution. So we balance hydrogen by adding protons, by adding H+. How many hydrogens on the left side? 2 times 2 is 4, so 4 hydrogens on the left. How many on the right? There are 2 hydrogens on the right. So we need to add 2 protons to the right side to balance out hydrogen. So we're going to add 2H plus to the right side. So we pretended like this was in acidic solution, but remember, it's actually in basic solution. So we can add hydroxide to both sides to remove the H+. So if we have 2 H pluses, we need to add 2 OH minuses. And if we add 2 hydroxides to the right side, we need to add 2 hydroxides to the left side. So let's write down what we would have for our oxidation half reaction. We would have 2 H2O, so we have 2 H2O plus cadmium, so plus cadmium, plus 2 hydroxide, so plus 2 hydroxide, giving us cadmium hydroxide, so CdOH2. And then what is this? What is 2H plus 2OH minus? H plus and OH minus would give you water. So we get 2 waters on the right side, so 2H2O. Next, we need to balance our charge. So let's look at charge for our oxidation half reaction. On the left side, what is the total charge? We have 2 hydroxides, so that's a charge of 2 minus. On the right side, we have a charge of 0, so an overall charge of 0. We balance charge by adding electrons. So how many electrons do we add, and which side of our half reaction do we add them? If we add 2 electrons to the right side, right, that would balance out our charge. So we're going to add 2 electrons to the right side. Notice we have 2 waters on the left and 2 waters on the right, so we can cancel those out and write our final half reaction. So cadmium plus 2 hydroxide give us cadmium hydroxide plus 2 electrons. So this is an oxidation, so we should be losing electrons here for our half reaction. We're ready to write our reduction half reaction. So next we're going to do reduction. So the oxidation half reaction occurs at the anode of our battery. The reduction half reaction occurs at the cathode of our battery. So let's go back up here so to see what we write for our reduction half reaction. Well, this is going from an oxidation state of +3 to an oxidation state of +2. That's a decrease or a reduction in the oxidation state. So this would be our half reaction, nickel oxide hydroxide going to nickel hydroxide. So let's write this down. So we have nickel oxide hydroxide going to nickel hydroxide for our reduction half reaction. We start by balancing our atoms. 1 nickel on the left, 1 nickel on the right. Then oxygen, 2 oxygens on the left and 2 oxygens on the right. So we can move on to hydrogen. How many hydrogens on the left side? There's only one hydrogen on the left, but there are 2 hydrogens on the right. So we are going to pretend like this is in an acidic solution. So we balance hydrogens by adding protons. So how many protons do we add and to which side? Well, we have 2 hydrogens on the right, only 1 on the left. So we need to add 1 proton to the left side. So we're going to add 1 proton, so H+. So now hydrogen is balanced. Next, we're going to get rid of the proton that we just added because really this is in basic solution. So since we have 1 proton, we need to add 1 hydroxide to get rid of that 1 proton. If we add 1 hydroxide to the left side, we need to add 1 hydroxide to the right side of our half reaction. So let's write down what we would have now. All right, so H plus and OH minus give us H2O. So we have H2O plus nickel oxide hydroxide, so H2O plus nickel oxide hydroxide, giving us, on the right side, we would have nickel hydroxide, so nickel hydroxide plus OH minus, so plus hydroxide. We need to balance charge next. So let's look at the total charge on the left. It would be 0. On the right side, we have 1 hydroxide anion, so that's 1 minus for the charge on the right. So we need to add 1 electron to the left side of our half reaction. If we add 1 electron to the left side, now the charge is balanced. It's -1 on the left, it's -1 on the right. And so we add an electron. Gain of electrons is reduction, so that makes sense too. So this is our half reaction. So this is our reduction half reaction. And we're ready to think about adding our 2 half reactions together. So let's go back up here. And remember, this was our final oxidation half reaction. So we lost 2 electrons. So we lost 2 electrons in our oxidation half reaction. When you're coupling together your half reactions, the number of electrons has to be the same, right? Because the electrons that are lost in the oxidation half reaction are the same electrons that are gained in the reduction half reaction. So we need to have 2 electrons for our reduction half reaction. So we could get 2 electrons by multiplying everything in our reduction half reaction by 2. So we're going to multiply everything through by 2. So 2 times 1 gives us 2 electrons. And then 2 times H2O, we get 2 waters. We get 2 nickel oxide hydroxide, so 2 NiOOH. We would get 2 nickel hydroxide, so 2 nickel hydroxide. And finally 2 hydroxide. So now we have the number of electrons. Now we have the number of electrons the same. So now we can add together everything to get our overall reaction for our nickel-cadmium battery. So we're going to add the 2 half reactions that I boxed. This half reaction and this half reaction, we're going to add them together. We can cancel out some stuff right now to make our lives a little bit easier. All right, we can cancel out these electrons on the product side, on the reactant side, and we can cancel out hydroxide, because if you look, let me change colors here. We have 2 hydroxides on the reactant side, 2 hydroxide on the product side. So now we can write our overall reaction. So for this half reaction, we would have cadmium. All right, so let's write that down here. We have solid cadmium plus 2H2O, so plus 2H2O, plus 2 nickel oxide hydroxide, so plus 2 nickel oxide hydroxide. What would we have for the products? We would have, well, let's go back up here to our oxidation half reaction. We would have cadmium hydroxide, so we write that in, so cadmium hydroxide, plus down here we would have 2 nickel hydroxide. So we have plus 2 nickel hydroxide. So we're finally done. This is the overall reaction for what occurs in a nickel-cadmium battery. And our two products, cadmium hydroxide and nickel hydroxide, are both solids that precipitate on the electrodes in the battery. And that makes it easy to reverse the reaction, right? Because if you're reversing your reaction, you need to start with cadmium hydroxide and nickel hydroxide, and those are already there. So it's easy to reverse this reaction, which makes it easy to recharge this battery. So the nickel-cadmium battery is like the lead storage battery. It's rechargeable, and therefore it can be very useful.